Today we're doing 3.3, which says corresponding parts of congruent figures are congruent. So this is a bit of a mouthful, but essentially this means that corresponding parts, right? So the say the left side of the triangle or the certain point that you've translated somewhere of congruent figures are congruent. And remember, congruent means it's the same size, same shape. So that means that the parts themselves are actually the same size, same shape. They give us this little rule here, and it's important to note that corresponding parts of congruent figures are congruent because it will come up again and again and again. I promise you that. And we can abbreviate this instead of saying the whole thing. Corresponding parts of congruent figures are congruent. We can simply say C, P, C, F, C. Corresponding parts of congruent figures are congruent. We'll do a real quick example, right? If I have two triangles, here's one triangle, here's the other triangle. Let's pretend that these are the exact same, right? If these are congruent, right? If they're congruent triangles, let me draw the congruent symbol. If they're congruent, then that means that this side is equal in length to this side, right? Because they're congruent lengths. It means that this angle is congruent to this angle. It means that this angle is congruent to this angle. Again, there's that subtle difference where it doesn't mean that they're equal. This angle isn't equal to this angle, right? They're different angles, so they can't be perfectly equal. However, this angle measurement will be equal to this angle measurement. So we can make this little distinction here between equal and congruent. Okay, so here's an example of a problem. They basically say that these two triangles are congruent. Therefore, we can basically set these sides equal to each other. We know that AB has the same length as DE, AC has the same length as FD, BC has the same length as FE, and all the corresponding angles are congruent. So this one, it just asks us to find the side length of DE. Well, we find D to E, and we know it corresponds with AB, therefore it's 2.6. Done. Similarly here, we can go down here, the measure of angle B, right? This angle here is congruent to what other angle? Well, as it turns out, it's congruent to angle E, which is 65 degrees, so therefore angle B is 65 degrees. Okay. Looks easy, right? We'll do harder ones in the future. The triangles shown in the figure are congruent. Can you conclude that JK is congruent to QR? Explain. How did I do this one? Yeah. So if the two triangles are congruent, we don't necessarily know the corresponding sides is the problem. Yes, it looks like they're symmetrical. It looks like QR could correspond with JK, but it could correspond with LK. And if we look at the order of the letters, we can see that it doesn't really match up either. So just be aware of that, just because something we need to figure out how they're congruent more than just that they're congruent too. Okay, so we have STU is congruent to VWX. Find the given side length or angle measurement. Go ahead and do both 4 and 5 real quick. Cool. So the first one, SU, is the same as VX, right? And then the second one, angle S, is the same as angle V here. Again, we can note our congruence. Since they list the points for this triangle, STU is congruent to VWX. We know that point S is congruent to point V, point T is congruent to point V, point U is congruent to point X, that sort of thing, just based on the order that they listed here. Similarly, we could say ST is congruent to VW, that sort of thing. Okay, last little bit, where I'm actually going to break up the video after this, but I just want to cover these properties of congruence, and then we'll jump into some bigger stuff here in the future. the properties of congruence are very similar to the properties of equality, and we have covered the properties of equality. There's the reflexive property of equality, which says that things are congruent to themselves. Makes sense. The symmetric property of congruence, which basically means that it doesn't matter what order we put things in, right? We can say this thing is equal to that thing, or, sorry, congruent, or that thing is congruent to the other thing, this thing. And then we have the transitive property. Remember the transitive property? If this thing is congruent to that thing, and that thing is congruent to the other thing, then this thing is congruent to the other thing. So just keep that in mind. They're all can be congruent to each other. Here's an application. Similar to the last one, they're just going to throw in a little bit of algebra here. I'll extend this one. Put this one up. So we need to find the measure of angle D. And angle D is over here. It's given as 6y plus 2. And the corresponding angle to angle D is angle A, which is 5y plus 11. So therefore, we can say that 5y plus 11 is equal to 6y plus 2 because the measurements are the same. 5y plus 11 equals 6y plus 2. And then after that, it's just an algebra problem. We solve for y. We can subtract 5y from both sides. We can add or subtract 2 from both sides, and we get y equals 9. We're not done yet. We have to plug it back in. We can plug it into either one, but we should get 56 degrees. Okay, see if you can do 6 or 7 real quick. What Okay, so 6. We just need to solve for Lm. So L to M, the corresponding side to Lm is GH. So 4x plus 3 equals 6x minus 13. And then again, we solve for x, plug it back in. Number 7, same deal with angle H. Angle H is given as 9y plus 17. The corresponding angle to angle H is angle M, which is 11y minus 1. Set them equal to each other, find y, plug it back in. Okay, we're going to pause here for the video. I'll do a new one for something else.